Hi, this is David Coley with an application video for this summer's Desmos Teaching Fellowship. Today I want to show you a graph that actually a student created about how to use Riemann sums to find the area contained within a curve given by polar coordinates. So the way this works is you type in your formula here. This is your curve. This three-toed blob is your polar curve. You have to type in the formula again using x. I'll get to that in a sec. And then you have your initial angle A, your terminal angle B, and you can see the sectors change appropriately. And the area, combined area of all 10 sectors is 5.36, which approximates the area contained within the curve. So today I want to show you just one small feature that went into the creation of this graph. So I'll switch to a blank graph. I have the same formula, r of theta equals sine of 3 theta plus 2, initial angle A equals 0, terminal angle B equals 1. For simplicity's sake, I want to stick to having one sector that starts at A, ends at B, and whose radius is equal to the radius of my graph when theta equals A. So I'll start by just drawing a circle with the radius when theta equals A. And you can see that the circle grows and shrinks. But I want to shade the inside. So here's what I'll do. Change the equals to less than or equals to. And mysteriously, the graph disappears. So I was talking to my student, and the workaround we came up with is this. Define a new function, which is equal to the original, except it uses x instead of theta. Turn off the display of the new function, and in my sector formula, change my r to f. And then to finish it off, just restrict theta to be between a and b. So now if I increase b, the sector grows appropriately. If I increase a, the sector shrinks appropriately, but the radius changes to meet the radius of the red polar graph. So this works. And this is the solution the student and I came up with. There's only one problem though. If I want to change my formula to, I don't know, sine of 4 theta plus 2, I need to change it twice for it to work out. And so with my student, we left it at that somewhat unresolved. In the course of actually making this video for Desmos, I figured out a way to circumvent having to type it in twice. Go back to your original r of theta formula and just use f in this definition. Then I can make f my primary function and change that once, and the whole graph will change accordingly. And there you go. There were a few other things that went into the creation of the graph, like how to make the sector appear when the radius defined by this formula is negative, and a couple other things. I'll make sure I have the link to the original graph included along with this video for your enjoyment. Well, this has been David Coley with an application video about Riemann sums and polar graphs. I hope you enjoyed, hope you learned a little something, and I hope to see you this summer. Thanks for watching.